Hello everyone, my name is Kyle Bailey, and in my problem presentation, I will be discussing how temperature change affects the measured resistance of a wire. In my problem presentation, I will be covering two major concepts. The first concept being how to measure the resistance of a wire when provided the dimensions of the wire, such as length and diameter of the wire, as well as knowing the material that the wire is made out of. The next concept that will be covered is how to measure the resistance of a wire when it is at different temperatures. In the problem, we are provided a wire which is 35 meters long and has a diameter of 0.5 centimeters. The wire is also made of nickel, which is provided that the resistivity of nickel at 20 degrees Celsius is 6.99 times 10 to the negative 8th ohms times meter, and the temperature coefficient of nickel is 6 times 10 to the negative 3rd degrees Celsius to the negative 1 power. With the information given, we are asked to find the base resistance of the wire, which is when the wire is at 20 degrees Celsius, and the resistance of the wire at 125 degrees Celsius. In order to solve both parts of this problem, we're going to need to use a total of 3 different equations. To find the resistance of the wire, we're going to use the first equation listed here, which reads resistance equals resistivity of the material of the wire times length of the wire over area of the wire. We already know the resistivity of the wire, as well as the length of the wire. However, we do not know the area of the wire, which is where this second equation comes into play. This is the equation to find the area of the wire, which reads area equals pi times radius of the wire squared. These two equations are what we are going to use to solve part A. And for part B, we're going to use the third equation listed. This is the equation to find the resistance of the wire at different temperatures. The equation reads resistance equals initial resistance times the sum of 1 plus the temperature coefficient of the material of the wire times the change in temperature from 20 degrees Celsius. To start part A, we must begin by solving the area of the wire using the area equation. To find the radius of the wire, we must take the diameter of the wire, which is provided, and divide that by 2. The diameter provided was 0.5 centimeters, which then means that the radius equals 0.25 centimeters. When converting this to meters, it comes out to 0.25 times 10 to the negative 3rd meters. Now that we know the radius, we can solve for the area of the wire. So area equals pi times 0.25 times 10 to the negative 3rd squared. When doing this calculation, we find that the area of the wire equals 1.96 times 10 to the negative 5th meters squared. Now that we know the area of the wire, we can now use the resistance equation to find the base resistance of our wire. We know that the resistivity of the wire is 6.99 times 10 to the negative 8th ohms times meters. We know that the length is 35 meters, and we know that the area is 1.96 times 10 to the negative 5th meters squared due to our previous calculation. We can now input these numbers into the equation, giving us resistance equals 6.99 times 10 to the negative 8th ohms times meters multiplied by 35 meters divided by 1.96 times 10 to the negative 5th meters squared. When doing this calculation, we find that the resistance of the wire comes out to 0.125 ohms. Moving on to part B, we must now use the third equation that was listed in order to find the resistance of the wire at 125 degrees Celsius. Unlike part A, we already know the value of all of the variables within the equation. For initial resistance, we measured in part A that it is 0.125 ohms. For temperature coefficient, we are given in the problem that the temperature coefficient equals 6.0 times 10 to the negative 3rd degrees Celsius to the negative 1 power. And for change in temperature from 20 degrees Celsius, we just do the simple calculation of 125 minus 20. When inputting all of these numbers into the equation, we get resistance equals 0.125 times the sum of 1 plus 6 times 10 to the negative third times 125 minus 20. After completing this calculation, we find that the resistance of the wire at 125 degrees Celsius equals 0.204 ohms. When comparing the measured resistance at this temperature, 125 degrees Celsius, and at 20 degrees Celsius, it can be seen that as temperature rises, so does the resistance.